trig functions of real numbers. To find the value of any trig function of any angle, first determine the value of the associated reference angle. That's what I've been saying. First find that reference angle, the angle trapped between the terminal side of our angle theta and the x-axis. And we're going to use theta prime to find out the trig values for theta. Part 2, depending on the quadrant which theta lies, affix the appropriate plus or minus sign to the function. So what does that mean? Well, you've got to know by heart this idea of all students take calculus, or all start Tim Curran. First quadrant, all trig functions are positive. Second quadrant, only sine, and of course cosecant, are positive. Third quadrant, only tangent, and of course you get cotangent for free as well, and is positive. And in the fourth quadrant, only the cosine is positive. And of course you get secant, it's reciprocal as well as positive. Evaluate each trig function. Cosine 4 pi over 3. Well, what do you think? Maybe we should draw it first. I love that I have a 3 in the denominator of this angle. Why? Because immediately I know my theta prime is pi over 3. That's the advantage of radians, or one of the advantages of radians, is that you can tell the reference angle right away. Now all I have to do, by the way, what told me this? I know that my reference angle is pi over 3 right away. Now here is 3 over 3 pi. What does that mean? Well, I'm taking 1 pi and cutting it up 3 ways. A 1, a 2, I'll put a big 2 in the middle here, a 2, and here is our third pi over 3. This is pi over 3. There's 1, there's 2, there's 3. Ah, we need one more. All right, let's add in one more. Here is pi over 3, and I've come up with 4 pi over 3. This is my angle theta. Here is theta. It's a monster angle. Theta prime is right here, and it's pi over 3. Doesn't say I can't, so I prefer to use the unit circle, which means this is 1. Across from 60 degrees, or pi over 3, is root 3 over 2. This has got to be 30 degrees, or pi over 3. So adjacent up here must be 1/2. And here's my right angle. But I'm going to this point, and we've talked about how this is quadrant 3. I'm going left from our origin 0, 0, right there, which is this point here, and I'm going down, so that's negative. Please take the time to make sure that these are right. It's just so heartbreaking for a student to get everything right and just be kind of a little bit lazy, not putting in the signs. Now, I take my baby blue eyeballs, stop me if you've heard this before, and I look through theta prime. They've asked only for the cosine of 4 pi over 3. Now, that's theta. I use theta prime of pi over 3 in quadrant 3 to find these trig ratios. That is going to be, I know cosine is always adjacent over hypotenuse, but when the hypotenuse is 1, that's just adjacent. There it is. I just have to pluck off the x. Negative 1/2 is my answer. So easy once I get my picture drawn. In our next example, we're asked to find the tangent of negative 210 degrees. Remember, that negative 210 just means we're going clockwise. Stop me if you've heard this before. Let's draw it. Here is 0 degrees. Here is negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360. When I see this, I say, all right, my angle is open clockwise, negative 90, negative 180. It doesn't reach all the way up to negative 270, but it certainly goes past negative 180. So our angle here is going to be this monster angle. Here is theta is negative 210 degrees. Now, negative 210 minus negative 180 gives us negative 30 degrees. But I'm going to take the absolute value of that. Do you see how much extra work I have to do to find that theta prime is 30 degrees? I like working with radians better because I could find my reference angle much more quickly. Or you could think of it as if I go to negative 180 here and I'm going to negative 210, I just have to go 30 beyond 180 in the negative direction. So once we have this, we can draw our triangle, and if we make this a unit circle, why not? Then that hypotenuse is 1. Across from 30, we have 1/2, and adjacent is root 3 over 2. But because we're going from the origin, this is in that negative direction. So please take the time to do that. So hopefully you can see that tangent of negative 210 degrees. We're going to plant our baby blue eyeballs looking through our reference angle. And from this perspective, here is our opposite and here is our adjacent. We know tangent is opposite over adjacent. So this will be 1/2 opposite divided by negative root 3 over 2 adjacent, which is keep 1/2, change division to multiplication, and flip this to 2 over negative root 3. Sorry, the negative's on the outside of the radical there. Cancel your 2's. Now, they don't cancel to 0. 2 goes into 2 once, and we're left with negative 1 over root 3. If we're going to rationalize this, we'll get negative root 3 over root 9, which is 3. So there is our answer. Not hard, not hard. You just have to know your stuff. Let's find the cosecant of 11 pi over 4. Now, a positive angle just means we're going to be going clockwise here, and of course, we want to draw this bad boy. So I already know my reference angle is going to be, you guessed it, because we have a denominator of 4, I know I'm going to be at pi over 4. So 11 pi over 4 is 11 times pi over 4, or it's 11 of these pi's over 4. And we're going counterclockwise. So let's do them. Here is 4 pi over 4, or 1 pi, and here is 8 pi over 4. All right, because that's 2 pi, right? So if I'm going to break these into pi's over 4, look what I've done. Each pi, each half circle, a 1, a 2, a 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, I was right. 2 pi is 8 pi over 4. 9, 10, 11. Oh, there it is. So our angle is this. There it is. 11 pi over 4. So here, this is our terminal side of our angle, and immediately I know that our reference angle, trapped between the terminal side of our angle and the x-axis, is pi over 4. If that's pi over 4 and we're talking about a unit circle, the hypotenuse is 1, and I have root 2 over 2 positive, so the y is going up, it's positive, and the x, or the cosine, is negative root 2 over 2. So this is important. Once I have this and this and this, and I know my reference angle, then I can find any trig ratio. I'm going to take my eyeballs and look through my reference angle, which, by the way, is in quadrant 2, where the sine, or the y, is positive and the cosine is negative. So now all that's left is to figure out what is the cosecant of 11 pi over 4. We know that's hypotenuse over opposite, or 1 over root 2 over 2. Keep, change, flip. Well, I can just take the reciprocal of that and get 2 over root 2. Of course, I'd want to rationalize that. So I get 2 root 2 over 2, and those cancel. So the final answer here is root 2. Not so bad. Notice it's positive, ASTC. The sign is positive here, but so is its reciprocal, cosecant. Another way to consider this problem is to write this improper fraction as a mixed number. Cosecant of, well, 4 divides into 11 pi twice with 3 left over. So this is 2 3/4 pi. So when I look at this, I go, well, here is 2 pi. So I can almost forget the 2 pi and just say, let's call this 3 pi over 4. And immediately I can quickly come up with this, pi over 4. And then away we go with the same idea that we just had, right? So what did I do? I canceled off the 2 pi. I considered 2 3/4 pi, 2 pi plus 3 pi over 4. But I know that every time I have a multiple of 2 pi, it just brings me back to where I started. So any even number of pi is going to be over here. By the way, any odd number of pi is going to be here. So I'm going to find 1 pi here, 3 pi here, 5 pi here, 7 pi here, etc. Here I'm going to find 0 pi, 2 pi's, 4 pi's, 6 pi's, 8 pi's, etc. So this is just saying go around the circle once, and then this is what's left over. And this is what I'm concerned with to be able to figure out what my trig function values are. So there's another way to consider that. Make it a mixed number, and then sort of work your way around even and odd pi's. Any even pi is going to be here. Any odd pi will be there. Here's what I mean about odd pi's being at pi. So if I was given this, I'd say, well, this is really sine of 3 goes into 35 11 times. 33 and 2 left over, and 2/3 pi, which is the same as sine of 11 pi plus 2 over 3 pi. So what does that look like? Well, I know 11 pi is right here. Look what I do. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. I wasn't kidding. 11 pi is over there. But do I really draw this mess of a picture? It looks like a hurricane. No, I just say, all right, that means we're starting with 11 pi over here, and I have to go 2/3 more pi. So I go, and so my reference angle is pi over 3. Look how quickly, -3 pi, over 3 over 2, and 1/2 and 1. Look how quickly I can draw my reference triangle using that little trick there.